Hello, testing, testing. Okay, I think volume is good. Bam. Alright, hello, everyone. Good morning, or afternoon, evening, wherever you are. This stream is kind of interesting. So, I am part of a charity fundraiser campaign for the LA fires. This campaign is hosted by Z, or Syzygy Altair, aka just Z. She has a lot of friends and colleagues who are affected by the LA wildfires. So, yeah, this specific campaign, the charity is Direct Relief. The platform we're using is Tiltify, and the funds are going to Direct Relief, and they're going to deploy like supplies, medical equipment to people in need. So, yeah, if you are interested and you really want to, and you can spare some change, feel free to help out Z and her colleagues in this fundraiser. Yeah, it's pretty cool. There are a lot of vtubers who are helping spread the word and participating. You can see Code Life over here, who we had a coding battle with. I think I know Pembu from Discord. But yeah, throughout this stream, a QR code will be on the upper right side, which you can scan and get the link to the dono link to, and it should be in the description to the dono link if you're on YouTube. Yeah, that's all I will say about. I can't talk. That's all I will say about this. Let's get to the Leetcoding. Okay. So I was really contemplating whether to do new problems this time or review old problems that gave us trouble. This is the 4th Python stream, right? Oh, for context, I'm trying to learn how to code in Python because my job uses it and I really suck at it. So I'm doing blind 75 LeetCode questions. I think today's a good time for review. I'm going to start forgetting the problems I did 3 weeks ago. So here we go. I've actually written down the questions that gave me trouble. First up is LeetCode 217. Hopefully y'all can see this. LeetCode 217 contains duplicate. Okay. Yeah, I'm still really struggling with Python, hence the struggle even on easy questions. Okay, LeetCode 217 contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Wait, given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Wait, isn't this pretty easy? How did I get this one wrong? Huh. Sounds like it's time for a hash set, no? At least in Java. My primary language is Java. So we take the list, for example this, we go from start to end, iterate through it, and Code Life. Oh, hi Code Life, hello. How you doing? So I think we go from start to end, right? And then for every element, we put it into a set. Hopefully I know how to do that in Python still. And then for every element too, if I've seen myself in the past in the set, then we return true. And else if we make it to the end, return false. That should be it, right? That sounds pretty simple. How did I get this wrong in the first place? Jesus. I did write. Kodai says, doing well, I wanted to check, do you get dono notifications? I don't. Oh yeah, speaking of the donos. Hold on. Last night I checked, we were past 314, right? Where is... Is there a way to wait, let me just grab the dono link from the YouTube studio. Oh, bam. No, I won't be shocked. I checked this morning. That's absolutely crazy. That's crazy, man. Yeah, I saw that we were above 1,000 this morning. Yeah, I was about to talk about like, yeah, let's get Z to do a dance challenge. But then we're already way past that. So now Z his merch is the next goal. I wonder what dance she's gonna do. Is it gonna be like, I don't know, a K-pop dance? I also wonder how she's gonna do it technically too. I know she has like hand tracking and face tracking. I've never seen her do a full body tracking before. Hi Pembu. Hello, what's up? Oh yeah. For anybody watching now, Code Life and Pembu are also in the Fire Relief Charity campaign. Pembu is the second one here, Code Life is the fourth one here. Heck yes, go support them too. Okay, back to the Leetcoding. I feel like this is really simple, no? Go from start to end for every element stored in a set. Also for every element, if I've appeared in a set in the past, then return true, else return false. Yeah, so the actual logic is kind of simple, but it's the implementation. I suck at Python, so we'll see how this goes. Okay, first we need a set, right? Nums, let's call this past nums. The nums that we've seen in the past is equal to new set. This is how you instantiate a set in Python, right? I hope so. And then we iterate through every single number for num in nums. We check if it's in the set. If num in past num. Code Life says, if you suck at Python, what am I? No, seriously, I just started learning Python. My previous coding language for Leetcode was Java, remember? If num in past num, then you return true, semicolon? No, there's no semicolon in Python. Else you return false. Oh, we also have to update the set with the numbers we see. So past nums dot, how do you put stuff in a Python set? I think in Java it's like this. Num. Hold on, I have to look this up. Python, how to put in set. It's add. Oh, it's add. Okay, it's add. Add. Okay, give me a second to log in and then we can run this code. My username is okay, we back. Let's run this thing. Runtime error. If num and past num. Oh, wait. Past num is not defined. Past nums, it's plural. Past nums, okay. Return true. Oh, I know this is in Python. The booleans are capitalized in the beginning. So I have to change this for false as well. Let's go. Let's go. Hey. Okay. I probably need to note this one down. Empty set. To add to a set, you do dot add. Okay. Sounds good. Wow. That went faster than I thought. Okay. Next up, so again, I'm doing problems that gave me trouble since 3 weeks ago, since I started learning this. So next up I wrote down Leetcode 152. Leetcode, let's make a new tab. Whoop. Leetcode 152. Maximum product subarray. Okay, this is a medium problem now. Given an integer array nums, find a subarray that has the largest product and return the product. Oh, the test cases are generated so that the answer will fit in a 32-bit integer. Okay. Oh, I don't remember how to do this. Output is, so you're given these numbers, output is 6 because 2 times 3 has the largest product 6. 2 times 3 is 6, times negative 2, you're going to go to the negatives. Okay. So negative 12, yeah. So you don't want to take this chunk, right? Because the negative here is going to take you to the negatives. Over here is just 0, because the result cannot be 2, because negative 2, negative 1 is not a subarray. Oh, because they're not continuous. Huh. I think I have a hunch of how to do this. I'm not confident though. I think we need to go from like start to end and then multiplying stuff. And then when we get to yeah, and then we keep track of our max. And then whenever we get to 0, because there's no coming back when you're multiplying by 0, right? Then you would restart your product count. Because there's no way you're coming back from 0 if you're multiplying by 0. It's just going to be 0 forever. Yeah, so go from start to end, multiply everything. Because there's always a chance that if you're multiplying by negative, you might see another negative in the future, right? And you're going to go back to the positive. So it's probably worth continuing and seeing if anything else makes it, you know, positive again. Yeah. All right. So start to end, multiply everything. Reset if we multiply 0. I think we have to do the same thing from this end too. You might get different answers if you multiply from end to the start. Because the max is like 4 from here. What if this is like 10? Okay, I think that's what I'll do. Let's start with the simple case. Let's multiply from start to end, keep track of the current product, track the max, and reset if we multiply 0. Yeah, okay, let's go. So we need to track our current product is equal to 1. Our max product is equal to 0, let's say. And then from start to end, for, okay, we need to do some index traversal in Python now. For I in range len nums, is this how you do it in Python? I think this is how you do it. For every I in range, so len nums will be 4. So it'll be from 0 to 3 because it's exclusive. Okay, I think that works. You know what? Let's do a sanity check first. Let's print out nums I. Let's make sure we're doing this traversal correctly. And now let's return something bogus. Run. Okay, we are printing out everything. That is good. I know how to traverse stuff in Python still. Okay, we need to multiply it with our product. Product times equals nums I. Yeah. And we need to update our max product too. Oh, hi Marissa. Marissa says, hello y'all. Hello. What's up? Today is a very interesting stream. We're helping doing LA Fire Relief Stuff campaign for charity. Yeah, As always, you can scan the QR code if you really want to above me, or the link is in the description for the charity link if you really want to. The max product is equal to, this is how you do max in Python, max. So we'll take the max of the current max product and the current product. Okay. And if the max product is equal to 0, then you reset everything. Prod is equal to 1. You start counting again at the next one. Okay, and then you return max product. I know there's probably cases we didn't cover yet, but I will submit for a sanity check. It should cover simple cases now, this thing. Oh, shizzle. Okay, this is definitely not completely right. There's cases if we go backwards, it's not gonna work right. We can submit and find out though. Yep. Okay, nums is -2, my output is 0, expected -2. Wait, why is my output negative for this? Oh, because my max product is starting off as 0, but it can go into the negatives, so we can go live. Says, good luck, Chet, I'm going to sleep. Nice catching you. Hey, no worries. Thanks for stopping by. Appreciate it. Good night. Code with Ven says hello. Hello. Hi, Ven. How you doing? Max product. We should instantiate this to negative, right? Instead of max 0. Yeah, okay. How do you do negatives? Or is it float negative infinity? I think that's how you do it. Let's use this test case. Run. Okay, nice. We need to go from backwards to start, right? I'm pretty sure that they're going to give us a test case too. Yeah. 3 expected for, let's use this. Yeah, I remember this. The max values you could get, the max product you could get multiplying from start to end is different from end to start, because here it would be like 4, and then you get to -1, 3. Yeah, we need to do the multiplication from end to start too. So basically copy this stuff. There's a way to do it all in the same loop, right? For I in range len nums. Should we call this like forward product? Forward product. And then we'll replace all of these with the forward product. Let's run this to make sure it still works. Okay, cool. Case 4 is still failing. Let me take off a layer because it's hot in this room. Oh. Okay, we need to compute the backwards product too. So let's say backwards product is equal to 1. And then we need to update our backward product too. Backward underscore product times equals. Okay, so we're starting at x0, right? Nums. How do we compute the backwards? Len nums. Len nums is automatically out of bounds, so we need to -1. And then we minus the current index. Yeah, that makes sense to me. So the max product is now equal to the max product amongst the max product currently, the forward product, and the backwards product. Okay. And then it's likewise if the backwards product is equal to 0, anytime and we reset it to 1 because there's no coming back if your product is 0, and you return max product. Run. Please, work. Hey, let's go. Uh-oh. Why? Okay, it's okay. Let's use this test case 203 negative 2. My output was 2, expected 3. Okay, why? Looks like it's time to start printing out stuff. Okay, let's print out our current I. Index. Now I. And our forward product, backwards product probably. Am I not multiplying the correct stuff? Nums, len, nums, -1. That should be right. Okay, the thing is, the forward product should be capturing this, no? Let's just print out what the forward product is. Print forward product. I like how in Python you can just print out like this really easily. Oh, I see it. We're saying max product is equals to 0. This should be forward product. Run. Nice. Get rid of all of our print statements. Submit. Let's go. Hey. Okay, Leetcode 152, review done. Next up is Leetcode 153. Again, I'm reviewing problems that gave me trouble in the past. Leetcode 153. Find minimum in rotated sorted array. Oh man. I remember this one. This one was painful. Okay. Suppose an array of length n sorted in ascending order. Okay, meaning it's... Oh, this reminds me of something. You guys want to hear a funny work story? Or painful work story? I had a project that was due, so I work at a software company, right? I had a project that was due on Thursday. Man, should I even be telling this story? Am I gonna be violating something? Basically, I'm pretty new at the company, right? And I was given a project, and I was told that something needed to be sorted in descending order for it to work, because we're ranking some stuff. So yeah, this was approved by like the founder. The founder looked at the plan and he was like, looks good to me. Senior software engineer was also like, looks good to me. Go implement this. And then I did. And the thing was, this particular task, it takes a really long time to test and write tests for, because every time I hit run, it would take up to, I don't know, 30 minutes. So every time every time it doesn't work and I need to debug it, it would literally take like over an hour or like hours. So anyways, I was working on this project with this parameter allegedly supposed to be sorted in a descending order, and then it was 5 p.m. already. You know, people usually leave work at 5 p.m., right? And then I was trying to debug some tests with the senior software engineer, and then we were like, why are all these tests failing? Why isn't it working? And then we realized, wait, it's not supposed to be sorted in a descending order. It's supposed to be sorted in ascending order, which means I had to test and do everything again. Like, yeah, do everything again. So I ended up sleeping really late that night. All because of descending versus ascending order. No. Oh well. I still got in on time though. I slept really late. That project was actually pretty interesting though. So at least it was for an interesting project. But yeah, ascending, descending, very important to get the wording right. Man, I'm not sure how much that story made sense, just because I don't think I can say what exactly I'm descending or ascending. Marissa says, reminds me of a math class. Somebody lost all points at a task because they made it ascending instead of descending. Bro, that really sucks. Everything is correct except ascending, descending. Why do ascending and descending have to cause so much havoc in the world? But yeah, when we found out that we made the mistake with ascending, descending, I like literally just laughed. It was like, wait, we're sorting these things in least popularity. That's like the exact opposite of what the purpose of this project was. We want to get the stuff with most popularity first, you know? So, I remember I just laughed. Because it's almost comical how the project is going against the goal completely. And also I'll have to sleep pretty late today, or that day. Okay, anyways, suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums. This thing might become this if it is rotated 4 times, and then this if it is rotated 7 times. Notice that rotating an array, this becomes this. Yeah, okay. Basically, you're like shifting it to the right, and then elements from the right pop back on the left because they have nowhere to go. Given the sorted rotated array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs in log n time. Yeah, I remember this one was difficult for me. Next project gonna end up like, help, I accidentally hacked the government. Oh yeah, speaking of next projects, I was watching another coding VTuber. Not VTuber, he's a flesh tuber. Another coding YouTuber called, I think it was called The Prime Time. He was also Leetcoding too, and he did something where he wrote a script that will delete all the files on his computer if he fails to solve the Leetcode question. I thought that was so funny. Like, I've never been I don't really know how to code in Bash very much, like he was doing, or like just write random scripts to do stuff on your computer and manipulate stuff on your computer. I think that's kind of cool, writing scripts to do that. I think it would be fun for a future stream if I also do something like that. Like if I don't succeed in solving a Leetcode question in a certain amount of time, some consequence will appear on my computer or something. Like, I don't know, maybe my browser explodes with rickrolls or something. I think that would be really fun. But yeah, it's given me a little bit of interest in learning how to write Bash code too, to like manipulate my computer. I think that's really cool. Excuse me. Okay, let's try to figure out how to do this problem. O of log n time, that's binary search, right? I remember that part. What I don't remember is exactly how to implement the binary search or how to modify the binary search. Okay, let's take a look at this. In regular binary search, right? I just realized I can probably just do 3 quotation marks like this and save me a lot of time for commenting. Yeah. Okay. So regular binary search, we saw you put your left pointer here, your middle pointer somewhere here, and your right pointer here. Marissa says, I once saw someone making Russian roulette, except it's PC version. It was basically if he loses his win. His Windows system gets deleted. What happens to the stream though? Does that mean his stream just ends? It's so horrible. He has a backup, right? Ideally he backed up his PC, right? It would be such a pain if he has to get everything back again. I'm not sure if I'm ready for stakes like that. Very crazy. It was a YouTube short? Oh. Man, YouTube shorts. I feel like I've been watching more YouTube shorts recently than actual long-form YouTube videos. Sorry, videos. It's a lot more convenient just scrolling up and up and up than actually choosing the video I want to watch. Am I getting too lazy? Okay. Anyway, 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3. Okay. Our middle pointer is over here. Okay. I think it's starting to come back to me. If our middle pointer, what it's pointing to, is greater than the left thing, then that means we're still on. That means we're on like the first half, right? We can roughly divide this array into like two sort of halves. Like this half is what was supposed to be on the right side when it was sorted in ascending order, and then this side is what was originally on the left side when it was sorted in ascending order. So we'll call this like half 1, half 2 for convenience, I guess. Yeah, so if M is greater than L, that means you're still on the first half and you need to close in on this half. So in the next run, you will set your L to like M plus 1. Yeah, and then R over here. And then the next run, you'll be like, okay, my M is over here. My M is greater than L. Wait, it's still greater than L. Wait, should I be comparing it to the right side instead? Yeah, maybe I should compare it to the right side. So if my M is greater than R, then I know that M is on the first half, and then I need to converge on the second half, so L goes here. Okay, that makes more sense. And then here, M is less than R, so you're like, okay, I know that I'm on the second half. Yeah, so my R needs to converge instead. So you're like, okay, R here, and then here M will be one of these things, right? And then LR would be the same thing, because M is less than R. Okay, I think I know how to do this now. Just keep comparing M to R, and then act accordingly, according to what we see here. Okay. This is much easier said than done. Oh. Okay. Calm down, Chet, you got this. Okay, let's do L is equal to 0, R is equal to the length of nums minus 1, because that's the rightmost index. Okay, and then while L is less than or equal to R, perhaps? Yeah. M is equal to their bisection, so L divided by, well, L plus R. Wrap these in parentheses. And then, is this how you do integer division in Python? Hold on. Python, integer division. Yeah, that's how you do it. I remember. L plus R, divide by 2. Okay, so now we need to compare M to R. Code with Ven says yep. Okay, thanks for confirming. Okay, if M is less than, or in this case, if M is greater than R, if the number at M is greater than nums R, then we close in to the right. So L is equal to M plus 1. Okay. And then else, can I just do an else statement here? I'm trying to think. So this is if M, the number of M is strictly greater than R. Could they be equal? Like if all these are 2s? Could I have, oh look, all the integers of nums are unique. Okay, so I can't just do an else statement because all the numbers are unique. They'll never be equal anyway, so I won't have to worry about complexities when it comes to that case. Else, R is equal to M. Should I do R is equal to M or M minus 1? So in this case, right, I'm moving R in. Should it be M or M minus 1? What if we did M minus 1 in this case? Then R will be automatically equal to... Oh wait. So in this case, we might move R to like past here, like that. So let's just do M, I guess. Sure, let's do M to be safe. And then we return... Should we return L perhaps? L is equal to M plus 1. Wait, which one do we return? They're all gonna be the same thing in the end, right? They're all gonna converge on the same thing. Maybe L is fine. Let's try this. Runtime error. Oh, my comments are horrible. Run. Oh, I sense a... Yeah, we loop too much. Okay, what went wrong here? While L is less than or equal to R, M is equal to L plus R divided by 2. Okay, I think it's time to print out stuff. Print. Let's print what L is. Does Leetcode support like string templates? L is L, comma, R is this thing, comma, M is equal to M. Okay, I think I tried doing string templates once on Leetcode. It didn't work for whatever reason. Maybe I just didn't print it right. Hopefully this works. R is equal to M, return L. Will it even print? Invalid syntax, okay. Bambrum says, why do you do R is equal to M? I want to converge in. That's my way of closing in on the left. It's for this case. So if M is less than R, then I want to close my R in to the left side and converge on the minimum. Yeah, that was my thinking. Should I do -1 instead? And also this print statement isn't working, no. Let's do L. Let's print L, and then print R minus R, and then let's print our midpoint to M. Man, binary search is confusing. Is it even gonna print stuff if we're on a infinite loop? Well, oh look, it does. Okay. We're getting somewhere. Okay. What even is this test case? 3, 4, 5, 1, 2. Okay, 3, 4, 5, 1, 2. Maybe I just copy this above so it's easier to see. Should I make this smaller? Okay, here. Okay, so in the beginning, L is here, 0, and 0, 1, 2, 3, 4. R is here, that's to be expected. M is equal to 2, 0, 1, 2. Yeah, over here. That's to be expected. So what do we do here? We know that M is on the first side, first half. So we need to move on to this side. So we're like, okay, L is now equal to M plus 1, which is 3. That's good. Okay, so L is now here. And then R is still 4. It's fine. M is now 3. So M is in the same place as L. M is 3. And then now we're saying everything is just 3. Oh shoot. Everything is just 3. So we should be doing well. L is less than R, right? And then we return L. Run. Greater than equal? Wait, greater than or equal? Wait, greater than equal? You mean this part here? Nums M is greater than or equal to nums R. Oh wait. What happens in this case if nums M is greater than or equal to nums R? Run. Don't you return nums L? Oh, shh. 3, 0, 1, 2. Oh, you're right. I should be returning the number at L. Num L, not the actual index of L. Plural. There we go. Oh. Haha. Also, I don't understand why this has to be greater than or equal to. If M is exactly the same as R. Oh wait, so in this case, if M is less than R. Oh wait, I think I'm starting to see it. Wait, do I? We actually don't. Nums M is greater than or equal to nums R. Oh, I mean, so L cannot possibly even be remotely the solution, right? So we can Wait, I don't get it. All the numbers are unique, right? So, yay. Let's try deleting the equals and see what happens. You don't need it. Wait, you don't need it. Alright. Also, let me delete the print statements. 100% baby, let's go. Okay. I think code with yen. No, I think there's a world where you can put like equal signs, but you also have to change some other places possibly. Yeah, I don't know. Binary search is tough, man. It's hard to wrap your mind around it. But yeah, thanks for the pointing out that I was returning the index. That was actually helpful. Hey, 100%. Cool. It actually doesn't matter. Yeah, because I was originally thinking, they said that every single number is unique, right? So we don't even need to worry about the equals case. Like, yeah, all the integers of nums are unique, so they will never be equal to each other anyways. But I was hesitating because it looks like they can, like, L, R, and M, there's a world where they can land on the same index, right? They can eventually land on the same index. Oh wait, hold on. L is always guaranteed to be less than R. So L and R will never be on the same index. What's M if L and R are right next to each other? 0, 1, 1 divided by 2 is 0. Okay, so if L and R are right next to each other, M is going to be equal to L. Yeah, so there's no world where M could be equal to R. There's like 0 chance. But M could be equal to L. Your solution could be L. Yeah. Oh, that's an interesting way to think about it. Basically, your solution will never land on R. M. Does this even make sense? Am I just talking nonsense? If L and R are right next to each other, M is equal to L. So if you're slowly converging in on the solution, your solution will never be R, but it has a chance of being L. So it's useless to compare if your M is equal to R, I guess. Does this make sense? I'm starting to get confused as I'm talking about it too. But, you know, it's still comforting that we can reach the solution by drawing some stuff out. I know I can reach the solution somehow. Okay, next problem. Actually kind of makes sense. Okay, thank you for confirming. Okay, the last problem I wrote down for review, I really don't know if I should do this. It's literally just 2-sum, because it's the first problem I ever attempted in Python and I really struggled on it, because I'm bad with Python. Should I do 2-sum? Is it worth my time to do 2-sum? Screw it, let's just quickly do it. This is actually the last problem I wrote down for review. Given an array of integers nums and an integer target, return indices of 2 numbers such that they add up to target. You may assume that each input would have exactly 1 solution, and you may not use the same element twice. You can return the answer in any order. Okay. Target is 9, 0, 1, 0, 1. Yeah, okay. You return the indices of the numbers that add up to 9. Ooh. Wait, twosome is harder than I thought. Bam Brum says, so idea is M would be L rather than R when we do the divide by 2, yeah. 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 What was I saying about that? Yeah, apparently the way we were comparing it, M, our solution, will never land on R. So yeah. Okay. Why did twosome get this hard? Okay. So we need to find the indices of the two numbers that add up to the target. Okay. It will be easy if they just said return the two numbers that add up to target 9, but we have to return the indices as well and make it efficient. Okay. What did we always do in twosome? You go from start to end, save the numbers you've seen in the past, but this time we need to track their indices as well. Should we do a key lookup? Yeah, sure. Let's do a hash map. For every single integer, you put it into the hash map, you put its key, which is itself, the value is its index. So you can do a really quick lookup of, have I seen the number in the past? Yes. What is its index? Okay. Cool. And then for every number, you see, okay, what's my complement, i.e. the number that adds me to 9, or the target. Have I seen in the past? If so, yes, return my index and its index. Else you continue. Okay. Sounds like a plan. Each input would have exactly one solution. Okay, that's very nice. Let's call this past nums. It's really similar to the first problem we did actually, except we need to track indices now. So we don't use a set now, we use an empty dictionary. For we need to iterate on index now. For I in range nums. Oh, the length. Okay, for I in range nums, we need to track what its complement is. Complement is equal to nums minus me. Like, let's say num is equal to nums I for convenience up here. Complement is equal to our target minus the current number. Basically the number we need to add to myself to get to the target. Okay. And then we need to check if we've seen the complement in past nums. If complement in the past nums we've seen, then we return, what do we return? A list? Okay, let's return a list of, you may return the answer in any order. Okay, let's return I and past nums fetching the complement. Okay. And then after this, if we don't have a match, we add myself into the dictionary. So num past nums, we add the current num mapped to its current index. And then we keep going to the end. And in the end, we return none, I guess, or empty list if we have no solutions. Okay, no clue this is gonna work. Let's run this. Let's go, I solved twosome on the first try. Yeah. Let's go, we're in the 65th percentile. That's fine. don't we return num instead of I? Instead of I? Nope, it says return the indices of the two numbers. Wait, that's why I said twosome is harder than I remembered. If it was just return the two numbers that add up to target, then we could use a set, right, instead of a dictionary. But they want the indices, so it's a dictionary. Yeah, it's actually slightly more difficult than I remembered. Yeah, it's like another layer deeper than the first question we did. Okay, yeah, we've done all the questions that I wrote down for review now. Like, we did 4 questions in 1 hour relatively quickly. Cool. You guys want to try a new question? Let's go back to blind 75. Find search in rotated sort array. Threesome? I think we did this one. Find minimum and rotate sort array. This one is Leetcode what? 153. Yeah, we did this. Let's do search in rotated sorted array. Okay. Cool. I probably did this one in Java probably. Let's see my submissions. Yeah, this one's in Java. Okay. And it's back in August, so I don't remember. Search in rotated sorted array. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, it's rotated. Yeah, this is similar to the previous problem we had. I don't need the definition of rotate again. I think I know what that is. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. So we're binary. Okay. You must write the algorithm with log n runtime complexity. Okay, so we're binary searching rotated array again. From memory, this solution is a bit different than the one we just did, right? Okay, so in this example, we're searching for target 0. We output index 4, 0, 1, 2, 3, 0, 1, 2, 3, 4. Yes, that makes sense. What if we're searching for 0 here? Okay. We can zoom in on this a little. Okay, so let's simulate this. As always, we have our left and right pointers here. How do we get to 0? 0, 1, 2, 3, wait, 0, 1, 2, 3, 4, 5, 6. So our midpoint is 3, 0, 1, 2, 3, here. Excuse me. Okay. What in the world do we do here? Should we compare to... Should we do the thing where we're comparing to the right always again? But that was for finding the minimum. Okay. I think we can do something kind of simple, right? If L is less than M, that means this whole chunk is sorted. And then you have no idea what happens over here. This could be an 8 that follows it, maybe, or a 9. So this... I feel like we have a good idea of what happens from here to here, 4 to 7, just knowing 4 and 7. We would know that everything from 4 to 7 is ascending. How do I label this? We know what's happening here. we don't know what's happening over here. Because we only know 7 and 2, right? Who knows? There could be like an 8 over here, you know? Good 9. So this is like the wild, wild west to us. Like this could be a 9, you know? There's no way we can binary search like a range like this. Okay, so I think what we need to do is let's focus on the part we know first. The part that we know for sure is ascending. If our element is in here, then we narrow our range down to here. Yeah? And if it's not in here, then automatically we can be like, okay, we need to search this chunk now. Okay. Wait, that actually makes kind of sense. We keep identifying the chunk that is sorted, and we can actually binary search in there. And if the element is not in there, we scrap that out completely and search the rest. Or if we know that the element is in the sorted section, then we continue binary searching regularly in the sorted section. Okay, that's really easily said than done. So in the case of 0 here, we know that 0 is not in the sorted section. So L is equal to n plus 1. And then R is there. Yeah. And then now you're just in a sorted section. I guess. And then you just do regular binary search here. If m is greater than, well, yeah, we're in the sorted section now. If m is greater than the target, decrement R, else decrement L. Okay. I think that's the plan. It's really easily said, but implementing it is going to be really confusing, I think. Okay, so we have L is equal to 0, R is equal to what? Len nums. Did they call it nums? Yes, they call it nums. Minus 1. Okay, trying to make space here. But wait, it can also be 8, 0, 1, 2 on the right half, right? Let's work through that example. Eight, 0, 1, 2 on the right half, right? So let's put an 8 over here. Okay, let's do L, and then R, 0, 1, 2, 3, 4, 5, 6, 7. 7 divided by 2 is 6. Wait, no, 3. 0, 1, 2, 3. Okay, M is here. And then we're searching for target 0. Okay. Okay, so like, okay, 4, 7, that's the sorted section. Is 0 over here? Nope, it's not. So we'll move into this side, the unsorted section. L is equal to n plus 1. So now L is here, R is here. And then we're like, okay, 0, 1, 2, 3, 4, 5, 6, 7. 4 plus 7 is 11, divided by 2 is 5. 0, 1, 2, 3, 4, 5. So M is here now. Okay, we're like, 0, 2. Oh wait, that's kind of different. 0 to 2. So 0 to 2 here now is a sorted section. Okay, 0 to 2 now is the sorted section. Is 0 in this section? 0 to 2? Yes. then we zoom in, or we move in on the sorted section. So L is now equal to M. Is that what we do? So it is part of this section, so L could be part of M. Oh, this is getting tricky. But yeah, we would continue binary searching through here. 0 to 2. Yeah, so we need to keep identifying where the sorted section is, right? Okay. I think I have an idea what to do. Keep identifying the sorted section. Is my number in there? And keep zooming in on the area it's on. Okay, let's try this. So while L is less than R, let's compute M, which is equal to L plus R divided by 2. Okay. So if the left is less than M, are all the numbers unique? All values and numbers are unique. Okay, we're good there. So this is the case where the sorted section is on the left. Okay, so is the number in here? Target. If the target is like greater than or equal to L and target is less than or equal to M, then you close in on this section. So R would be equal to M, close in the left side. So this is if, if target is in sorted section, and then else target is not in the sorted section, then you converge in on the right half. L is equal to M plus 1. I think that's how it's working. Oh, this is getting kind of complicated. If L is less than M, so else, if L is greater than M, what would be the case if L is greater than M? Oh, here. The one that Bam Brum was talking about. If L is greater than M, then that means the sorted section is on the right side. Okay. Sorted section is on the right. Oh boy. Okay. So if the target is on that side, in the sorted section, if target is greater than or equal to M and target is less than or equal to R, then you converge on that side. L is equal to M, else, that means it's on the left side. R is equal to M minus 1. Okay. What do we return here? Can we return the left as usual? target is greater than or equal to M, and target is greater than or equal to R. Here, let me zoom out. This is gonna be such a pain to debug. Oh boy. Can L be the solution in any of these cases? If target is in the sorted section, so yeah, target could be equal to L here. If it's not in this completely, then L is equal to M plus 1, okay. If target is greater than or equal to M, L is equal to this, okay. You know what, let's just run it and see what happens. Oh, I sense the infinite for loop again. No, time limit exceed, okay. Time to start printing out stuff. Okay. Let's print out stuff at the end, maybe. You're comparing indices instead of the actual number. Holy shizzle, I'm dumb. Yeah, you're right. No. Let's do num underscore L. The L number is equal to nums L. Right number is equal to nums R. Dang, I keep doing this. M num is equal to nums M. Okay. Underscore num. Left underscore num. M underscore num. If target is greater than L underscore num, M underscore num, M underscore num, R underscore num. I only need to compare the numbers in the... Okay, let's run this. Runtime error. Oh, it's plural. Bambram says also, would it be an idea to use in 2 and 1, 2 returns true? Oh. Yeah, that could be convenient. Like in range, I guess. Time limit exceeded. Okay, it is time to start printing out stuff. Let's print it out over here. Can I just copy what I printed out on the last code? Your music turned off? Oh. Oh. I think I know why I turned off. I just turned off my wireless earbuds. Let me see if I can reconnect them. Please, reconnect. Connect. There we go. While L is less than or equal to R. Wait. Like if target not in nums return -1 could be the first line before the binary search. If target not in nums. Oh, I see. That's taking care of a... I see, you're trying to take care of a edge case when it's not in there at all. target is 0. I mean, ideally our code should take care of that case. Code with Ven says, well, L is less than or equal to R. Hey man, that's what you said the first time. Are you sure this is the case? I think I'll print out stuff first. And then... yeah, we'll see if we need that. Maybe we do. Who knows? Run. This code is so long too. By the way, should I be printing out the indices or should I be printing out where it looks like we're stuck at 4, 4, 5, 4, 4, 5? You know what? Let's run the nums actually. So it's easier. We don't have to keep counting the indices. Underscore num. Run. Okay. Also, wait, target is greater than mnum. Okay. So let's copy the problem here, all the way up here. And let's see what we have. Zoom in on this. Okay, we start at L is equal to 4. L is here. R is here. And then M is 7, okay? M is 7 over here. Now this part. So apparently we went from this to L is 0, R is 2. Oh wait. So we did this, and then R. Right? L is now equal to 0. R is 2, and then M is 1. Wait, okay, this looks good. This looks good. And then now we move to here. L is 0, R is 1. So we converged R this way. Okay, that's looking good. R, okay, that's good. And then M is also at 0, so M is at the same place as L over here. Oh, wait. 0, 1, and then we're just stuck on 0, 1, 0 forever. 0, 1, 0. Okay, we know the issue now. It's just how do we fix this? Okay, so M is literally equal to L. Okay, so what is this? Sorted section is definitely sorted section is on the right. If L num is less than N num. If L num is less than N num. So we're getting to here, maybe? Sorted sections on the right. Is L less than M? No, it's equal, so we're going here, which is good. If the target Wait, so ideally we want to move R this way, right? To the right. R is equal to n minus 1. Morton says, I'm sorry, but I need to leave now, but I will leave the stream on. Goodbye. Oh, good. Thanks for stopping by. I appreciate it. If target is greater than or equal to mnum. Ooh. I think I need to copy this downward so I can see better. Okay. So this part is the spot that's going wrong. L and R right next to each other on the right sorted section. I think we're on this side, right? If the target, which is 0, the target is 0, right? Target is 0, okay. Oh, my brain, it hurts. Okay, so here, if L_num is less than M_num, no, that's not true, so else, so L could be the solution here, else, if target 0 is greater than or equal to M_num, meaning it's in range. If target is within the sorted range, if it's greater than or equal to M_num and target is less than or equal to R_num. Huh. I mean, we want to get to here somehow. If the target 0 is greater than or equal to M_num. My brain. Sorted section is on the right. If target, I mean, we're just landing in this section over and over again, right? Oh wait, so M is exactly equal to our solution now. What if we just straight up did if M is equal to M underscore num is equal to the target. Return M. Return the index of the target. Run. Oh boy. Expected -1. Oh, okay. So we return -1 here if we don't see the solution. Let's go! I predict we're gonna have some issues that we're gonna solve, but that's okay. We're making progress. Oh, sick. Expected 0. Oh. 1, target is equal to 1, return -1. Wait. Expected 0. Okay, let's use this test case. Okay, let's run that. Let's steal back these print statements. Oh wait, they're already here. If m is equal to target, return m. Ooh. Wait, you might be right. Bambra might be right. If num But yeah, we are not even entering the while loop over here. Oh, shizzle. We're not even entering the... Is it actually worthwhile to enter here? And then we can be like, if num is equal to target, return m. Let's see where this takes us. Cool, accepted. I should really stop printing. Delete this. Time limit exceeded. Okay. Let's submit without printing. Wait, we might actually still be... Yeah, we're still... No, we're still getting a infinite printing stuff. It's okay, let's debug. Oh, this problem, it's pain. I probably need to write this down for review as well. Excuse me. Time limit exceeded. Okay, we're just getting 131. Okay, what is up with this? Excuse me. Target is equal to 2. Oh, which doesn't exist. Huh. Wait. So we don't have a way to return -1. So we're on 1313, okay. So in this case, m would be 1. L num is less than m num. Okay, so this is treated as m is on the right side. Huh. Should this be treated as m is on the right side? Target is 2. What if I put an equal sign here? Because m is exactly equal to L here. So if L is equal to m, if the target is in the sorted location, which it is, R is equal to m, so it converges. Run. Let's go. Submit. Let's go! We did it, boys. Oh. We beat it 100%. Gosh dang it. Oh, man. That was so much trial and error and looking at examples. Oh. My brain is dead. Okay. Man, if you told me to come up with this algorithm on the fly without any trial and error, I don't think I would be able to do it, unfortunately. How would I even come up with this? Can we run through this? Like, how would I even figure this out without any examples? Like running through any examples? Well, L is less than or equal to R. Okay, so obviously if M is equal to our target, you return M. Sorted sections on the left. Man, we have a common theme now. We're kind of pushing our answer into the left, like left could be the answer. Target is in sorted section. If target is greater than or equal to num and target is less than or equal to M underscore num, so it's on the left chunk, R is equal to M. Okay. Huh. So M, R is equal to M. You know what? I'm so confused. Why does my code work? This code is literally the product of so much trial and error. I don't even know anymore. Yeah, I'm definitely marking this down for review. This is Leetcode 33. It's such a low number. This is one of the earliest problems that they came up with, and it's so hard. Okay. Well, I will not be able to tell you why I chose specific greater than or equal signs, but I can explain what the code is doing, I guess. So we're doing regular binary search, right? We first determine what the sorted section is, because, for example, this chunk is like a sorted section, right? If you take like, I don't know, this chunk, that's not a sorted section. 7, 2, like what? This is the unknown section. Yeah, like for example here, this is your known section. This is your unknown section. Anything could be happening here. So you first identify the sorted section, the section that you know is for sure sorted in ascending order, and you're like, okay, is my target in the sorted section? Yes, no, okay. And either put away the sorted section if it's not in there, or only focus on the sorted section if it's inside. And then you slowly converge your search range based on that. Yeah. I want to see what other people did. This looks kind of similar to what I did. Okay, what did this guy do? While, oh yeah, I forgot you could instantiate everything in one line. I keep forgetting you can do that in Python. While L is less than R, less than or equal to R, M is equal to that, yes, the midpoint. If, oh nice, they did the, if nums M is equal to target, return M as well, which is what I did. Oh, interesting. They did all these -1s, +1s. If nums L is less than nums M, L is less than M, which means that's the sorted section, I guess, on the left. And nums L is less than or equal to target, less than nums M. So that means it's on the sorted section on the left. Then R is equal to M -1, L is equal to M +1. Okay. Oh, I see. The way they're doing this, so they're shoving the... Okay. I think I'll worry about the greater than or equal signs later, but I see what they're doing. So else it's not on the sorted section, so shove it to the right. And else, if the sorted section is on the right, if nums is between m and r, l is equal to m plus 1, r is equal to m minus 1, return -1. Okay, that makes sense. Okay, I want to study, maybe just think about a little why they chose the specific greater than or equal signs. So if nums l is greater than or equal to m, which means m could possibly be, the target could possibly be m and l. If l is less than target, so r is equal to m minus 1, okay, because r has no chance of being the answer. Else, if l is not equal to the target, l is equal to m plus 1. Okay. And then here, nums, so the target could equal to r. I see. So in this place, the target could be equal to r, so it doesn't matter if you're incrementing l. And then else, if the target has no chance of being equal to r at all, r is equal to m minus 1. Alright. Alright. I feel like my code is pretty similar, except they did it a slightly more elegant way. I like how they did, wait, in Python you can just do this. That's insane to me. Wait, that's actually really elegant. I want to try that too. Wait, that's so elegant. You can't do this in Java. Less than or equal. That's so elegant. Run. Wow, I really like that. Wait, ChatGPT, explain. How does this work in Python? Is shorthand for checking if the value of target lies between. It's a form of chained comparison which Python supports and reads. Dang, I really like this. It's so like readable too. Okay. Wait, I should write this down. This is so convenient. Between comparisons, you can do if A less than B less than C. I like that. Okay, I definitely wrote this problem down for review. Okay, I think that's the last problem I'll do today. We literally did 5 problems today. That's pretty good. Before I go again, my fellow VTuber acquaintance Z, full name is Syzygy. I keep forgetting how to pronounce her name. It is, yeah, I wrote it down. It's Syzygy. I wrote down the exact pronunciation. Syzygy Altair, aka just Z, which is usually how I refer to her. Yeah, she's doing this very well-intended LA fire relief charity campaign, since she has a lot of friends and colleagues that are being affected by the LA fires too. Yeah, I was really happy to be part of this campaign to help spread word of it. I'm not in the stage where I take donos from viewers yet, but just helping spread the word of her, very well-intended movement is good enough for me. So yeah, if you guys really want to and want to help out, support her charity for direct relief, feel free to do so. The QR code for the donor link has been on the top right the entire stream and also in the description. But yeah, thank you everyone for coming. Thank you Z for including me in part of this. Wait, let's see what other VTubers are up to now in this schedule. So this was me, Python Leetcoding with Chet. Penboo is doing teeter.io. I think, what's teeter.io? Is that like, I forgot what that name is. Tetras.io. Yeah, it's Tetras. I think it's Tetras. Probably. Yeah. Penboo will be playing Tetras at 3:30 p.m. Neko will be playing Fortnite at 6:30 p.m. And then Z will be doing a charity recap on Sunday tomorrow at 6 p.m. with the Open VC. I'm probably not going to be in the Open VC. Probably going to be eating dinner or something. But yeah, this is a pretty cool campaign. Okay, thank you everyone for coming. I appreciate. See you on the next stream. Bye.